3, 2, 1. Hello, myself Yaresh from GM University. Today we are explaining the machine learning model, which is a project-based learning. The topic name is the basic price prediction of mobile phones under the guidance of Mr. Vinay HS, Department of ISC and GM University. And our problem statement holds the project aims to develop a system that helps the user to rate a mobile and receive uh, personalized recommendations. Our objectives involves to develop a dynamic interface, efficient recommendations. One. This is our code part, which involves we are importing the necessary tools. Alright, we are first going importing the libraries we need. These are like tools, Flask for building the web app, Pandas and NIMP are for handling and processing the data, and then we have got some skitty-learn tools for doing machine learning stuffs like scaling, predicting, and finding similar fonts. JobLib helps for a save model. OS just a Unity for a file management. The app is equal to Flask, the name. This line actually starts a Flask app. Think of it like saying, hey Flask, let's build a website. We pass a name, Flask known, where to look for the templates and files. Setting up a global variables like def is equal to none, model is equal to none, scalar is equal to none, knn is equal to none, branch is equal to which is we are loading in the further process. Load and pre-process data. The data set which has to be shown. 3, 1. And this is our data set where a CSV file which attributes like brand name, model, price, average rating, 5G or not, a processor and a brand name, and a course, a processor speed, battery capacity, fast charging, etc. are our attributes, available attributes. Next, we are basic cleaning by command of df is equal to pandas.read CSV file. The basic cleaning, the brand name, which is a brand, RAM capacity RAM, internal memory or storage, a brand capacity as a battery, and a number of rare cameras, refresh rate, which is defined as a refresh rate, screen size, and is equal to screen size, processor brand, which is a processor. Let's convert a storage to a GB. We're using pandas and instances and in X. Next one. Here def convert to GB. The phone might list their memory as a 128 GB or a 1 TB, right? This function converts everything to GB. So if something says 1 TB, it becomes a 1024 GB. This way we are dealing with the consistent units. Then the numeric features, RAM, storage, and for our features in the numeric features, here we are checking each numeric column like RAM, storage, battery, etc., and making sure they are all numbers. If there are any missing values, we will fill them with the median value for the columns. It's a way to avoid error data. A brand is equal to stored def brand string upper the line which we are explaining. Finally, we grab all the unique brand names, turn them into uppercase for a consistency, sort them in alphabetically. This list might be used for a drop down menu for selecting brands on the web page. And if name main function runs, this is like saying if you run the file directly, first load the data and then start the web page. Debug true helps show useful error messages while we are developing. So what we have got here, the foundation of the mobile price prediction app. The rest will be continued by Darshan PS.
Hi, I am Darshan PS. I am today explaining the. Let's go step by step and explain each part of and the machine learning. In machine learning, set of feature selection features. RAM, storage, battery, screen size, refresh rate, rear cameras. You are using 6 numerical features to predict smartphones price, RAM, storage, battery, screen size, refresh rate, and number of rear cameras. Preparing data in Python. Def knn k nearest neighbor is equal to def features plus price propan. Variable x knn is equals def knn features. Variable of y knn is def knn price. You clean the data set by removing with missing values and separate it KNN fixtures. Why KNN is equals to target variable price. And next, scaling for KNN. Python in scalar is equals standard scalars, and X variables transform X KNN. Use standard the features like mean is one, which is important for distance based algorithms like K nearest neighbors setup. In this, the KNN is and neighbor S n neighbor metric Euclidean, and KNN fit train a KNN model to later find similar phones. Based on features, it uses Euclidean distance to compute similarity. And further linear regression model with pre-processing. In this numeric transform line, step is equals simple inputter strategy in median scalar, standard scalar. Pre-processing pipeline like fills missing values with the median, scale the features with standard scalar. And preprocessor equals column transform and transformer. Numeric transformer future. Wraps the numeric transformer in a column transformer, so it can be used with a full. And model is equals pipeline steps. Preprocessor or preprocessor model fit variables x comma y. Full machine learning preprocess the data, trains a league to predict price. The functions run only once when the server starts it. Load the dataset and models, make them available globally for other routes. Routes in app route, def return render template, and in bracket index HTML brands is equals brands. Renders the home page pre-assembly the form for user input in index HTML. In predict route, app route predict methods post def predict handles from submission when the user wants to predict a phone's price. Input data is RAM, float request from RAM. Input def PD data frame input data. Reads input from the HTML from converts it to a pandas data form. Predict price is equals